everyone. I'm Natalia Vassilieva. I am field CTO at Cerebras, and I oversee all of our ML projects with our customers at Cerebras. Really excited to be here at NeurIPS, and this year our team brought a lot of interesting work to share with the show. Broadly, I think we can divide all of the work streams in three broad categories. So we have some part of the teams working on efficient training and learning training dynamics, understanding how to run large-scale model training stably. So we have several works towards that topic, and among those are things like new updated version of maximal update parameterization, SUPAR. So Nolan is your guy to talk about that. That gives you an opportunity to initialize the model and to train that with hyperparameters which are invariant with respect to sparsity and not only width of the model, which MUP, standard MUP does. Really well-written paper, also highly recommend to read that. In the same bucket, we also have work primarily by Gavia and Joel on how to use gradient noise scale to, again, improve stability of the training processes. There's also another work which is not officially at NeurIPS, but we presented here at the booth anyway. Mostly talked to Daria about that. We are looking into a mixture of experts, and we are also learning into what impacts the training stability and learning of the experts in those models. So the team came up with several very interesting observations about different choices of routers to help understand how they impact ability of the models to train and ability of experts to differentiate between each other. So again, all of that work is towards enabling us to train more efficient models, to spend more compute and to train very accurate models. So training efficiency bucket. The next bucket is what can you do with the inference and how you can make inference more performant, both more performant in terms of time and latency, throughput, but also more performant in terms of quality. So we have several works in that direction as well. So works on pruning, on iterative distillation, use of draft models, and works on how to use inference compute to induce some reasoning into the model and improve significantly the quality of the outcome. So with that latest work, the team actually was able to show that with the very smart prompting and those reasoning techniques, self-correction techniques, you can get Llama 70 billion to perform on par with Llama 4 or 5 billion without any changes to the weights. So it all happens at inference time. Really exciting. Requires several calls to the model, but luckily with very fast inference on Cerebras, we can afford that. So it's a really promising direction for us. So second bucket, inference, how to make it faster and more accurate. And the third bucket is on applied work and what we do with our customers and partners. So into that category, we have a couple of works presenting here, one at workshop at NeurIPS and another here at booth. One, how to train and actually continuously train Llama for material science domain and how to teach Llama to understand language about chemistry and material science. And another one is how to train foundational genomic models. So in collaboration with the M42 and Inception, we've trained foundational genomic models, which are competitive with some state-of-the-art models for structural predictions on top of genomic data. So that's another example of applied ML work that the team does. Please come see us. We see a lot of posters, a lot of excitement, ready to share additional details about all of that work the team's doing.